Hi everyone, my name is Will Valida. I'm a software engineer and a cloud architect, and in this video we're going to talk about how we can use memories in the Semantic Kernel SDK. Memories are a powerful way to provide broader context for our prompts. We've always called upon memory as a core component for how computers work, just like the RAM in your laptop. Memories in the semantic kernel are what make computations relevant to the tasks that we want to perform. We access memories to be fed into the semantic kernel in one of three ways, and this video will focus on the third way. So first up are conventional key-value pairs. Just like we would when we set environment variables in our shell, we can do the same using the semantic kernel. We just do a conventional lookup because it's a one-to-one match between the key and a query. The second way is using local storage. When we save information to a file, it can be retrieved with its file name. So when we have a lot of information to store in a key value pair, it's best to do this using local storage instead. And finally, semantic memory search. You can represent text information as a long vector of numbers, known as embeddings. This enables us to execute semantic searches that compares meaning to meaning with our query. Like I said, memories are possible through embeddings. Embeddings are a way of representing words or other data as vectors in a high-dimensional space. Vectors are like arrows that have a direction and a length. High-dimensional means that the space has many dimensions, more often than we can see or imagine. The idea is that similar words or data will have similar vectors, and different words or data will have different vectors. This helps us measure how related or unrelated they are, and it also enables us to perform operations on them. Embeddings are useful for AI models because they can capture the meaning and context of words or data in a way that computers can understand and process. So why are embeddings important with large language models? Since a prompt is a text that we give as an input to an AI model to generate a desired output or response, we need to consider the length of the input text based on the token limit of the model we choose to use. Taking GPT-4 as an example, this can handle up to 8,192 tokens per input. This means that texts are longer than the token limit of the model will not fit GPT-4 and may be cut off or ignored. So embeddings are useful for breaking down those large pieces of text into smaller pieces. We can do this by summarizing each large piece of text into shorter pieces of text and then generate an embedding vector for each summary. An embedding vector is like a compressed representation of this text that preserves its meaning and context. We can then compare the embedding vectors of our summaries with the embedding vector of our prompt and select the most similar ones. We can then also add those summaries into our input text as context for our prompt. This way, we can use embeddings to help us choose and fit large text as context within the token limit of our chosen model. So embeddings are useful for a variety of different scenarios, such as text classification, where embeddings can help the model assign labels or categories to text based on their meaning or context, or text generation, where embeddings can help the model to create new and original text based on the input or the prompt that the user provides. We can also use embeddings for such scenarios like code generation, image generation, and text translation. Now, where do vector databases come in? A vector database is a type of database that stores data as high-dimensional vectors, which are mathematical representations of features or attributes. Each vector has a certain number of dimensions, which can range from tens to thousands, depending on the complexity and granularity of the data. The vectors are usually generated by applying some kind of transformation or function to the raw data, which could be text, images, audio, video, and etc. The main advantage of a vector database is that it allows for fast and accurate similarity search and retrieval of data based on their vector distance or similarity. This means that instead of using traditional methods of querying databases based on exact matches or predefined criteria, we can use vector databases instead to find the most similar or relevant piece of data based on their semantic or contextual meaning. For example, we can use vector databases to find images that are similar to a given image based on their visual content and style. We can find similar documents to a given document based on their topic and sentiment, or we could find similar products to a given product based on their features and ratings. Now today, Semantic Kernel offers a variety of connectors to vector databases that we can use to store and retrieve information. So in this demo, what we're going to do is we're going to see how we can use the Semantic Kernel SDK to work with memories and then use Azure AI Search to store our embedding data so we can use that for our memories. Okay, so here I am in Visual Studio. Now, in previous videos, I've used kernel arguments to pass additional text into prompts, which enrich them and provide them a little bit more context to help chat with our AI agents using Semantic Kernel. However, solely relying on kernel arguments does have its limitations, such as the model's token limits. So to overcome this, we can use Semantic Kernel's Semantic Memory, and in this demo, we're going to leverage Azure AI Search and use that as a persistent semantic memory storage. So if I go into my CS proj file, I've installed a couple of packages already. So I've installed my configuration.json NuGet package. I'm going to be loading a bunch of settings from my app settings.json file. I've already installed Semantic Kernel, and I've installed connectors to Azure AI Search and OpenAI. And I've also installed this Semantic Kernel plugins.memory package, and I'll explain what that is in a little bit. But just to talk a little bit about the connectors available in Semantic Kernel. In the Semantic Kernel GitHub repository, we can see there's a whole bunch of connectors that you can use to a variety of different vector databases. So there's one for MongoDB, another one for Redis, SQLite, and there's Azure AI Search. So you're not just limited to Azure AI Search, it's any kind of vector database that you can use for your embedded data. Cool, so let me go back into Visual Studio. Cool. Now, in order to use memory, what we need to do is we need to instantiate the memory plugin with a memory storage and an embedding backend. So in this example, we're using Azure AI Search. So what I'm going to do is I'm just going to copy and paste some code, put it underneath line 24, and make sure I'm adding that using statement. Fantastic. Okay, so at its core, semantic memory is a set of data structures that allows us to store the meaning of text that comes from different data sources. And we can also store the source text and any other metadata that we require. And this text can be from the web, it can be from email providers, chats, databases, local directories, etc. And they're all hooked up to the semantic kernel through memory connectors. So here I'm connecting my Azure AI Search memory store to the semantic kernel. The texts are embedded, sort of compressed into a vector of floats that represent mathematically the text content and also the meaning. And I've explained that a little bit earlier in this video. So if you want to go back just to try and reinforce that concept, please do. Okay, so let's create some initial memory. So what I'm going to do is I'll just copy and paste this, and I'll just explain it. So what I'm doing here is I'm defining a constant for a memory collection name, and this will be the name of the index that we create in Azure AI Search. And then I'm storing 5 pieces of information. So it's all about me. So my name is Wolf Leader, work as a lead software engineer, currently live in Melbourne since 2023, families from the Netherlands, etc. So what we can do from that, we can actually, once we've inserted that into Azure AI Search, we can actually search the memory for that. So what I'll do is I'll just copy and paste this, and we're just going to ask a very simple question: what is my name? So this is going to be my query, and I'm going to search that memory, or search the collection name, ask it the question, set a limit of 1 answer, and then for each item in the response, this comes back as an asynchronous enumerable. We're going to ask the question and then see what it answers with. Cool. So what I'm going to do now is just run that. Cool. So I've asked it, what is my name? My name is Wolver Leader. So if I actually get out of this and go into Azure AI Search, Give that a refresh. And I can see that About Me has been created. And if I search that, I should see a whole bunch of data. So there's a whole bunch of embeddings, embedding data that have been created using that embedding model from Azure OpenAI. And here is the information that I've saved to this collection. So my family's from the Netherlands, currently work as a lead software engineer, and we should all see that. So essentially what we've done is we've used this memory store in Azure AI Search to basically ask questions of our AI agent. So my name is Wolverleader. So by asking it, what is my name, it's been able to retrieve that information. Cool. So let's go back into Visual Studio. Now, in previous videos, we've talked about using kernel arguments to fill the prompt with a history that continuously gets populated as we've chatted with our AI agents. And we can actually enhance this even further by adding memory to it. So what we can do is we can do this using the text memory plugin. And this exposes a recall native function. So that recall native function will actually take an input and it will perform a similarity search on the contents that have been embedded in the memory store. And then by default, the recall function will return the most relevant memory. So what I'm going to do is I'm just going to copy and paste a prompt, and then we're going to create a function from that prompt. So essentially what this prompt is doing, we're basically saying, okay, this chatbot can have a conversation with you about any topic. It can give explicit instructions or say, I don't know, if it doesn't have an answer. And we're saying, okay, information about me, recalling from previous conversations. And we're using this recall native function to actually recall facts that we've provided to our semantic memory. Then we're actually creating a function from this prompt here, using this semantic kernel prompt, and also providing some prompt execution settings since we're using Azure OpenAI to generate the answer for us. Cool. Now, what we can do is we can use a relevance parameter, which is used in a memory search. And this is a measure of the relevance score between 0.0 and 1.0, where 1.0 means that's a perfect match. And you can experiment with different values depending on your use case. So what we need to do is just provide this with some kernel arguments. I'm going to do this quite explicitly. So it's going to be the same question as before. What is my name? But it's also where do I live? Where is my family from? Where have I traveled? What do I do for work? And then I'm going to add some more arguments using the text memory plugin. So first up, I'm going to state, okay, use this memory collection name that I defined earlier, and this is our Azure AI Search Index. This limit parameter is how many results or relevant results, depending on the question that I've asked, and the relevance parameter, as I talked about before. Cool. So now that we've included our memories, we can actually create a method to start chatting with our AI agent. So I'll just copy and paste that. So I'll declare an empty string for a history. And then as part of my kernel arguments for my history, we'll just add to the history each time we chat with the bot. So it'll take a user input. We will then use all of these arguments that we've defined to kind of invoke this chat function that we've created here. And then we'll get a response for a result. And every time we get a response, that result will be appended to this history array. And then we'll just write out the question and the result that we've got. So what I'm going to do is I'm just going to invoke this method 3 times. I'm just going to ask it 3 simple questions. Okay, so hello, I think we met before, remember, my name is, ask what my name is, see if it can recall that. I want to plan a trip and visit my family. Do you know where that is? I'm asking it, do you recall where my family is? And great, are there any fun things to do while I'm there? Cool, so let me give this a run. Cool, so there we go. So here are my 3 questions. So hello, I think we've met you before. Remember, my name is, and he goes, yes, I remember you. Your name is Wolverleader. How can I assist you? Obviously, it's not very interactive, this conversation. These are just examples that I'm using for the purpose of this demo. I want to plan a trip and visit my family. Do you know where that is? Yes, your family's from the Netherlands. Is that where you'd like to visit? Are there any fun things to do there? He goes, yeah, there are many things to do in the Netherlands. You can visit the famous canals in Amsterdam, go and see tulip fields in Lies, visit one of the many museums, such as the Rijksmuseum or Van Gogh museums, two fantastic museums. Definitely go and check those out. So what our semantic kernel AI agent has done, it's used our Azure AI Search vector database. It's used the embeddings to recall information that we've stored in there, and it's using that as a memory to say, okay, I remember what your name is. I know your family is living in the Netherlands. Here are some things to do while you're there, which is pretty cool. So let me go back into Visual Studio. Cool. Now, there may be times in your applications, or lots of times in your application, sorry, where you'll want to bring in external data or documents into your memory. And we can actually do this using Azure AI Search as well and Semantic Kernel. So, what I want to do is I'll copy and paste this. We're going to create a new collection name called Programming Websites, and we're going to store a bunch of data related to websites for learning programming. So, getting started, the Go programming language, Go by example, learn Rust, introduction to Rust by example, Golang tutorial for beginners. And these are all just, titles and also websites to learn either Rust or Go. A little bit of a foreshadowing of what content I might do in the future. And then from this, we can actually add these articles to Azure AI AI Search Semantic Memory. So what I'm going to do, just copy and paste this. So for each item, I'm actually going to save this reference in this new Azure Search index that I'm going to create. And I've identified the source, description, text. For the external ID, it's just going to be the key of this dictionary, while the description and text is just going to be the value of that. Cool. So now what I can do with this is we can actually, once we've added these files to Azure AI Search, I can ask questions like this. So just copy and paste that. I want to learn more about Rust. Which website should I check out? So what I can do, I'll just copy and paste this as well. I can use Semantic Kernel Memory to search the collection that I've created. Here's my ask. So I'm asking the question, I want to learn more about Rust. Which website should I check out? I've got a limit of 3 results, and then also the minimum relevant score should be higher than 0.8. And then for each item in this code memories list that I'm going to get, I'm going to write out the URL, the title, and also its relevant score. So let's give that a go. Cool. So we can see that the programming articles have been added to Azure AI Search Semantic Memory, and it's come up with 3 responses to our question, I want to learn more about Rust. Which website should I check out? So it's got Learn Rust, Learning Rust, and also taking your first steps with Rust. And all the relevant scores are pretty high up as well. So what I might do, just change that to Golang instead and give that a run. And there we go. So instead of results about Rust, I've got results about Golang. So learn Go on Code Academy, getting started with Go, and Go by example. 3 great websites to start learning Golang. Cool, so that wraps up this demo. In this video, we talked about how we can use memories in Semantic Kernel and how they're a powerful way to provide broader context for our prompts. We've learned that we can access memories fed into Semantic Kernel in one of 3 ways, and in this demo, we focused on Semantic Memory Search. And we learned that memories are possible through embeddings, which are a way of representing words or other data as vectors in a highly dimensional space. And this is important because prompts that we give as an input to our AI models could be larger than the token limit of the model that we're choosing. So embeddings are really useful for breaking down those large pieces of text into smaller pieces. And then we also learned that vector databases are a type of database that stores data as highly dimensional vectors. And each vector has a certain number of dimensions, which can range from tens to thousands. And the main advantage of vector databases is that it allows for fast and accurate similarity search and retrieval of data based on their vector distance or similarity. If you enjoyed this video, please give it a like. And if you want to see more videos on Semantic Kernel, don't forget to subscribe. If you have any questions, please pop them in the comment section below. And no matter where you are in the world, I hope you're having a great day, and we'll see you all next time.